Welcome to True Projects. In this video, we are going to explain about Deep Retinex network for single image dehazing. Introduction. A Deep Retinex network is suggested by the project for single image dehazing. The project introduces a novel end-to-end picture dehazing network as well as a Retinex-based decomposition model for hazy images. The model separates the natural illumination for the haze-free image and residual haze-caused illumination from the illumination of the hazy image. A multi-scale residual dense network for estimating the residual illumination map and a unit with channel and spatial attention mechanisms for image dehazing make up the proposed Deep Retinex Dehazing Network (RDN). Using the illumination error loss function and the dehazed image error loss function, the RDN is optimized from beginning to end. The project demonstrates that the suggested RDN outperforms state-of-the-art approaches on public, synthetic, and real-world dataset. Objective. The project's objective is to suggest a Deep Retinex network for dehazing a single image. The proposed network intends to jointly estimate the haze-free image and the residual illumination map. The objective of the project is to create a network with greater generalization capabilities independent of past knowledge, avoiding the flaws in simplified scattering model. Using the illumination error loss function and dehaze image error loss function, the proposed network is optimized from beginning to end. On publicly available synthetic and real-world datasets, the project's goal is to outperform state-of-the-art approaches in terms of performance. Requirements. The requirements of the project are hardware requirements and software requirements. In hardware requirements, we have operating system Windows only, processor i5 and above, RAM 4GB and above, hard disk 20GB and above. Software requirements. In software requirements, we have Python IDLE with 3.7 version. Methodology. To implement this project, we have designed the following two modules. The first module is Generate and Load Retinex RDN model. In this step, the Retinex RDN model is generated and loaded into memory. The model is pre-trained using a large dataset of hazy and haze-free images. The network architecture typically consists of several layers, including convolutional layers, residual blocks, and other components that allow the model to learn complex features from the input images. Second module is Run Single Image Dehazing. The process of single image dehazing involves enhancing the quality of a hazy image to make it clearer and more visually appealing. This is achieved using the Retinex RDN model. The following steps are involved. Input hazy image. A hazy image is fed into the Retinex RDN model as the input. This image contains reduced contrast, color distortion, and decreased visibility due to the presence of haze or fog. Feature extraction. The input hazy image is processed through the convolutional layers of the Retinex RDN model. These layers extract various features from the image, capturing information about its content, texture, and structure. Retinex enhancement. The Retinex theory is a color vision model that aims to separate the illumination, lighting conditions from the reflectance surface characteristics of an image. The Retinex RDN model incorporates these principles to enhance the hazy image. It effectively estimates the illumination and reflectance components of the image and then combines them to create a dehazed version. Deep learning refinement. The use of deep neural networks allows the model to learn complex relationships between the input hazy image and the desired dehazed output. Residual blocks and other architectural components aid in capturing fine details and removing haze-induced artifacts. Output dehazed image. The final output of the Retinex RDN model is a dehazed image that has undergone significant improvement in terms of visibility, color accuracy, and overall quality. This image can be used for various purposes such as visualization, analysis, or further processing. Execution. For the execution of the project, we need to open the code folder. This is the code folder. This is the HDBD dataset, in which we have HDR high dynamic range photos and LDR low dynamic range photos, which are used during the execution of the project. And this is the model folder, which contains algorithm information. These files can be loaded into the project code during runtime to utilize the train model. This is the test images folder, in which we have the test images which we have used during the execution of the project. This is the main code file. This is run.batch file. Instead of executing a project in the command line interface, we have created Windows batch file to execute the project. Double click on run.bat file. A graphical user interface will pop up. This is the graphical user interface which we have created using Tkinter library in Python. Using this GUI, we will interact with the project. Click on generate and load Retinex RDN model to load the model. After loading RDN model, we will get the RDN PSNR and RDN SSIM values. Now click on run single image dehazing to upload an image. Select the image. I'm selecting the first image and open. So here we can see that the first image is the original image and the second image is the dehaze image using RDN Retinex. Now close the image. Let us select another image. I'm selecting the fourth image, open. So here we can see that first one is the original image and the second one is fully dehazed image obtained from RDN algorithm. And similarly, we can upload and test any hazy images. And above image we collected from the test images. Close this and exit the GUI. And the final conclusion of the project is the project's findings show that the proposed deep Retinex network for image dehazing outperforms state-of-the-art techniques on publicly available synthetic and real-world dataset. The simplified scattering model's traditional model mistakes and the traditional Retinex-based dehazing methods reliance on prior knowledge are avoided by the suggested Retinex-based method. The proposed network reinforces haze-free picture learning by integrating both channel-wise and pixel-wise attention mechanism into a unit to accomplish a trade-off between over-dehazing and under-dehazing. The suggested strategy is supported by experimental findings on synthetic and real-world datasets.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.